What's up, ninjas? Brendan here, and welcome to 7 Days of Injective. For day 1, we will be doing some basic setup. We will get ourselves ready for blockchain development on Injective. First, we'll connect to the Injective testnet and grab some data from it. Then we'll learn about public key cryptography and generate a seed phrase for using wallets. Then we'll install a wallet and configure it for Injective. And then we'll do some faucet to get some funds into our wallet. And then we'll be ready for development on Injective, on Injective testnet specifically. And that's it. So let's start off with JSON RPC. What is it? So JSON, JSON, stands for JavaScript Object Notation, and this is a lightweight data interchange format. It is easy for humans to read and write and easy for machines to parse and generate. RPC stands for Remote Procedure Call, a protocol that allows a program or a client to cause a procedure to execute in another address space or a server. In the context of a blockchain, the client is your DApp or your wallet, such as MetaMask, or a script or program that you write. And the server is the blockchain node, in this case, an Injective testnet node. Now, this is a standard way to interact with EVM or Ethereum virtual machine chains. Now, when you want to read data like a balance of an account or write data, such as to send a transaction, you need to send a JSON RPC request to the blockchain node. And the request and the response are both in JSON format, which makes it easier to read and write and therefore also easier to debug compared to binary protocols. The next thing we're going to do is to connect to the Injective EVM testnet over JSON RPC. Now, to do that, we're going to go to dots.injective.network, right? And in there, click on EVM developers and then click on EVM network information. And then in these tabs, select EVM testnet. And you'll get the basic information about how to connect and interact with Injective EVM testnet over here. Now, this is the one that we're interested in. This bit over here, this is the JSON RPC endpoint, right? So you could use a wallet or a DApp to interact with that RPC endpoint, but now we're going to go a little bit lower level just so that you can see the basics in action, right? In order to do so, we're going to be using curl. So that's a command line tool, curl, and it allows you to interact with all of these different protocols. The one that we're interested in is HTTPS because that's the one that the RPC endpoint is in. And also, coincidentally, that's the one that you use in your browser as well. All right. So I'm going to copy this command and explain it bit by bit. So this command here is curl-x for posts. So you can send different method names. For example, get is a common one and post is another one. So all RPC requests are sent via post. And then we're going to send a content type in the header requesting that it is going to be in JSON format. Is that all JSON RPC has to be in that format. And then I'm just going to make this a bit bigger. And then we have the actual data that we send inside. So this is the request body. And you can see it's in JSON. In this case, we're going to do ETH_block number as a method name, which doesn't need any parameters. So if we were to do that, let's hit enter, and then we get this. This number is the hexadecimal representation of the current block number. Now, if you take a look at the block explorer, so going back to here, let's click on this link over here. And we go to testnet.blockscout.injective.network. So this URL here, that's the Injective EVM Network Explorer. And you can see here, there's a new block being produced every 1 or 2 seconds. It's really fast. And if I go and repeat this command, you'll see that this number increases, right? So this last couple of digits is 58, then 97, and then that's going to cycle around, right, to A3. All right, there we go. So the numbers keep increasing. Now, this course is going to be primarily focused on Injective EVM testnet because that's the staging environment where you can experiment, etc. Mainnet is something that we won't be using throughout this course because that's for production and not necessarily useful for learning. But In this particular case, I'm going to demonstrate it by repeating this command, right? So I'm going to delete the RPC endpoint for Injective testnet and copy, paste the endpoint for the mainnet instead. And you'll see that you'll get a very different block number, right? So the block numbers on the two different networks, they increased independently of each other, right? And we go back to testnet and we get back to the testnet series of numbers. So yeah, we have interacted with the Injective EVM using on Injective testnet using the JSON RPC methods. All right. Now the next thing we're going to do is to talk about seed phrases, cryptographic key pairs, and accounts. So this one is mainly theoretical, right? You just have to know a hierarchy of entropy, mnemonic/seed phrase, then a seed, then a private key, then a public key, then an address, right? Now, if you have a private key and a public key and address, if you get those three things, then you have a blockchain account. But to get there, there's a whole process. So we'll start off with entropy, which is basically random noise. And you use that to generate a very large random number, right, to the order of magnitude as the number of atoms in the universe. That's how big it is. And the intent is for it to be virtually impossible to guess or randomly figure out what it is. Then we go to the seed phrase, right? So this random number, this very large random number is converted into a set of dictionary words from a specified list according to a BIP39 or BIP39 standard, right? And so this list of words obviously is human readable and therefore easier to back up than a raw binary string or that very large number. And, you know, just it's a usability thing more than anything else, right? Then that seed phrase is converted into a seed, and then that seed is used to derive a private key. Think of your private key as a master key for your wallet, right? To operate your account with. This can also be thought of as a password. So do not give it to anyone. It is secret. Hold it and guard it with high levels of secrecy. If it gets out, then basically your account is compromised and you can expect that actors with malintent may drain your funds from that particular account, right? Then next up, we have the public key. This is derived mathematically from the private key using elliptic curve cryptography. Now, that's a complex topic and out of the scope of this course, but if you'd like to learn more, I'll leave a link in the description below. And from your public key, what you do on EVM networks is that you can simply take the last 20 bytes of the hash of the public key and then do some formatting, and then you've got your address, right? And that's basically it, right? So you'll have, at the end of the process, you'll have your address, you'll have your public key and your private key. And note that this whole derivation process is unidirectional. It can only happen one way, right? It is, you can go from private key to public key and then to address, but you can't go in the other direction. And there's good reason for this, right? You can share your address and your public key publicly, as the name implies, but you should never share your private key, right? And since your seed phrase and that very large random number, those two can be used to derive your private key, you should also never share those either, right? So only your public key and your address should be shared. Everything else is secret. Now, what is this all for? So if you have a private key, public key, and address, you've got yourself an account, a blockchain account, right? But, right, what is that account useful for, right? So the private key component of that account, that's what you use to sign a transaction. You use cryptography and you take your data, i.e. your transaction, and you sign that data, and the signed transaction will be submitted to the blockchain network for verification by the blockchain nodes. And if it is indeed valid, which includes checks for other things, including the signature, then that transaction will be added to the network. But if it isn't, then it'll be rejected. Now, how does that actual verification occur? Because if I don't have the private key, if the blockchain node doesn't have your private key that you sign the transaction with, how does it actually do that? Now, that is where public key comes in, right? So the way that public key cryptography works is that the private key and a public key come in a pair. And if you have the public key, you can verify that it was indeed signed with that particular private key without actually knowing what that private key is. It's pretty fascinating, but again, not within the scope of this course. So again, check the link in the description for more information, right? So there you go. That's the reason why that's the reason why we have this whole setup process to get to a blockchain account. The other thing I'll highlight about accounts on blockchains is that you'll notice that none of this actually needed a third party, right? You don't need to go to somebody's website. You don't need to use, get permission from anybody. It is permissionless. You could, in theory, do all of this on pen and paper and create your own blockchain account. Of course, you won't really do that for practical reasons, but in theory, you could, right? In practice, you will use wallet software to do it. But that being said, the wallet software does not actually, rely on any authority or entity to control it, right? It is completely just governed by the rules of mathematics and cryptography. All right, next up, we're going to create an EVM wallet. So the first thing we're going to do is visit this website that I have over here called, whose domain is iancoleman.io, and go to /BIP39 for BIP39. Now, this website helps you to understand what actually happens behind the scenes when you actually create a new blockchain account. Basically, the process that I just talked about earlier on, you get to see it in action. So over here, select 12 words, then press generate. And here you go. You have 12 dictionary words. So these are much more easy to remember than, say, like a very large number such as this one, right? Okay. Then the next thing is I'm going to do code account.txt, right? And I'm just going to put my seed phrase in it and save it, right? We're going to just save this in a temporary text file for later use. Now, one thing I'll stress is that the method that I'm using here with this is strictly for learning purposes only. You would never operate an account using this method that I'm about to show you. So this is okay because it's testnet and we're all learning, etc., right? But this is far from being secure enough. So do not use this method for other purposes. All right. So now we've got our seed phrase. Derivation path, we don't need to touch anything over here, right? Essentially, hang on. I forgot one thing, which is that over here for coin, we need to select ETH for Ethereum. So that will work on Ethereum and other EVM networks, including Injective. All right. So with derivation path, we leave it alone. And so what this will do is it will have that derivation path that's selected above with indices, right? That increment of one at a time from 0. Now, what this will do is it'll generate several addresses, right? Several different accounts, each of them with their own address, each of them with their own public key, and each of them with their own private key, using the process that I described earlier on, right? It has all done all of that for you. So click on the CSV tab and copy the first few, paste them over here, and there we go. Now we have a few addresses and a few public keys corresponding to those addresses and a few private keys. So these are several accounts that have been generated using this process. All right. The next thing is that we are going to actually install a wallet. And for this, we'll use MetaMask, right? So let's go to this website, metamask.io. And inside of there, they'll say, select the browser that you're currently in. So that should be Chrome. Click on the button and then press add to Chrome. That'll install the extension. And we can close that and that. And now we've got MetaMask. So what we're going to do now is we could press create a new wallet, but we've already done that, right? So we're going to reuse these values that we have already. So press I have an existing wallet and then press import using secret recovery phrase. And what that really refers to is a BIP39 seed phrase or mnemonic. And we copy the seed phrase from here. So bamboo all the way through to rubber and then paste that So we've got our 12-word seed phrase here. Then we press continue. All right. One thing I'll stress here is that it's asking for a password. This password is not a seed phrase. Rather, this password really is just a way to encrypt your MetaMask data on disk, right? Just for some additional security. But this is not a password in the sense of a username and password or email and password combination that you get on websites. Because with those, if you forget your password, you can just press reset and they'll email you a link to reset it. There's no such thing. This, if you lose your password here, it is permanent, right? No one can do anything. You can't even contact MetaMask support or anything. And that's the case with any blockchain wallet. All right, so acknowledge and then press create password and then continue and your wallet is ready. Let's press open wallet and here we go. So we've got a wallet here and let's close these ads, right? And other networks, you'll see that there's Ethereum and that there's several other chains, but we do not have Injective available as one of them. So what we're going to do next is we're going to connect to the Injective testnet. Now, in order to do this, right, we need to supply MetaMask with the details necessary. Thankfully, all that information is available right here in the page that we've been looking at. So let's do click on the network again, click custom, add custom network, and then we'll just do Injective testnet. And then for RPC URL, we will copy, make sure it's on Injective EVM testnet tab, and then copy this and press add RPC URL, paste that there. Chain ID should be this. And then for symbol, it should be INJ. And then for block explorer URL, copy link and add URL and paste. All right, so it says Injective testnet was added successfully. So now you can see that we're connected to the Injective testnet successfully, but it says INJ 0. And that's not very useful because in order to do any transactions, we need to have at least some INJ to pay for gas fees, which are essentially payments for the cost of executing a transaction. And in order to do that, we are going to claim some testnet INJ for transactions from a Injective faucet. Now to do that, let's go back to the EVM network information page, and under faucet, you'll see that entry. We're going to go to this, which is at testnet.faucet.injective.network. Now, what you're going to do is copy the address of the account over here, and we paste it under EVM address, and you'll see that that gets populated over there. Then we can click on the MetaMask button, and you see account 1 over there, and you press connect, and there we go. So those are two different ways, right? So if I press that connect, then that fills in the EVM address. Otherwise, you can copy and paste it in manually. Then I'm going to press I and human and solve the CAPTCHA. And likewise. All right. Okay, then I'm going to press request tokens. Wait for the spinner. Now, I've already requested some testnet tokens today, so I might get rate limited. If I do, then I'll just use another faucet instead of this one. Okay, so sometimes that happens, right? The transaction occurs in the background, but then it couldn't find the funding transaction. So what we'll need to do next is to copy this address and look for that in the Injective block explorer. Okay, so that hasn't been funded quite yet. Aha, there we go. So we just had to wait for a bit longer. right? So now the wallet has updated and it says now I have 1 INJ, right? So now I've got a balance and now I'm able to send transactions. So we claim testnet INJ for transactions from our faucet. And then the next thing that we are able to do now that our wallet is funded, is that we can perform a transaction on the Injective testnet. Now, we won't be doing that right away, right now. Instead, we'll save that for day 2, where we will programmatically send transactions from this account. Congratulations. We have just covered all the theory plus demos for day 1, which got us set up and ready to go for development on Injective. Now, if you haven't gone through the steps yourself yet, shown in this video, please be sure to do so now. It'll only take a few minutes to complete. So once again, you have a couple of options. One is you can rewatch this very video from the beginning. And the other option is to follow the text instructions in the tutorial linked below. In the next video, we will have a short quiz with a few multiple choice questions. So I'd like you to watch that and self-assess your understanding of this topic. But before you go, note that this is a preview edition of the video that is part of the 7 Days of Injective course. We're creating the full version of this course with all of the bells and whistles. And if you watch this far, I'm sure that you will be keen on that too. So do sign up using the form by scanning this QR code or clicking on the link in the description of this video. For now, on to the next video.